Hi, welcome back. I'm Jeremy Foster. Thanks for watching this course on Node.js and the Internet of Things using Intel Edison. This module is on using a Node.js module for controlling hardware. This is a really good idea for a couple of reasons. First, it's easier, shorter, and more expressive code. By that I mean it's easier for someone that hasn't seen your code before to tell what's going on, and that's a really good thing. And the second reason it's a good idea to use a module is because it adds a layer of abstraction, and it means that you'll be able to run the exact same program on any device that's supported by that module without having to change your code. So you write software for turning your Edison into a robot, and then you want to swap the Edison out for a Raspberry Pi? Done. First, I'll teach you about and demonstrate two of the most popular modules for talking to hardware devices. The first is called Cylon.js. The second is called Johnny5. Both are pretty great, actually. There are cases where I'll use one and cases where I'll use the other. Next, I'll drill into the Cylon library and show you how to use what it calls drivers to talk to the various hardware components that we're talking about. I'll even get you pointed in the right direction if you need to write your own driver. Now, some of the components that you interact with will be a bit more complicated than a simple pin interface and will instead use the I2C bus. We'll see how that works too. Finally, we'll look at some other Node.js modules that I think you'll find very helpful when you're working on an IoT project. Let's go ahead and start with the Devices module. The first module is Cylon.js. Cylon implements a cool, modern, fluent API. It does a really good job of abstracting away the hardware, and it even gives your device a web interface and its own API. That means that after you target your device and implement all the components, you can expose them to other services on your network, or even give folks a basic web page where they can click a button and make a motor turn. That's pretty cool. We'll see some examples soon. Here's the basic framework code for writing a Cylon.js app. You would write this code in the main app.js file of your project, and that's the file that you'd execute using Node. Let's break this down. The first thing we do is we require the Cylon library. Then we call Cylon's robot method that's responsible for defining our device. The nomenclature is a little off here. What I've been calling a device, our Intel Edison in this case, is referred to as a robot by Cylon. This robot definition is made up of a few simple components. First, a name. This is how we're going to refer to our robot later on in the work function. Next, there are connections. This is the driver that's going to be used. Since we're using an Edison, we're using the Intel-IoT driver. Do keep in mind that Cylon's going to see this and go looking for a package with that name Intel-IoT and prefixed with Cylon-. So we're going to need to npm install the Cylon-Intel-IoT module in order for this to work. Next, a list of devices. In this case, Cylon's referring to all the things that you've hooked up to your robot. In this case, we've simply defined pin 2. Notice that we specified the direct-pin driver for this device. That string needs to match one of the built-in drivers that Cylon recognizes. In this case, direct pin simply allows functions like digital read and digital write. Other more specific or involved drivers allow more abstract control of your devices, and you can even write your own. Next, the work function defines what should happen once the robot's all set up and all of its devices are ready to communicate. This is sort of like the main function in a C program. And finally, the start method kicks the whole thing off. And that's sort of all there is to it, to a Hello World app for Cylon. One of the other very cool offerings of the Cylon library is its ability to automatically generate an API in a user interface. Let me explain. So you've built your Cylon robot, but now you have another program or service running somewhere else on your network that you want to be able to interface with this robot. Maybe your Cylon robot is a vacuum cleaner and you want your home automation system to be able to start it up. So you turn on the API, and then the other program is able to connect to it using standard interfaces like HTTP, MQTT, and Socket.io. In a connected architecture with multiple robots, this makes for some really exciting possibilities. To get more information about the API, go to cylon.js/documentation/API/HTTP or to MQTT or to Socket-IO. There's even a front-end application written in React that knows how to talk to the Cylon API, and it automatically creates a standard user interface for humans to look at. This might act much like the UI that you use to configure your Wi-Fi router. All in all, it's pretty slick. Johnny 5 is another really good option for talking to devices. The API is a bit less abstract and easier to understand, so it may be a better choice for beginners or the mildly intimidated. As far as I can tell, Johnny 5 is not quite as robust. I don't see automatic API and user interface generation, for instance. But actually creating your own API and UI might not be too hard. Might be something you might want to endeavor. The device and component driver support's very rich in Johnny 5 though. Let's take a look at a basic Johnny 5 program so you can compare the syntax to what you've seen of Cylon and make the best choice for you. The code is certainly terse and readable. We obviously need to require the Johnny 5 module, and then we need to bring in the specific device driver for our Edison. Then we instantiate a board that represents the device for the rest of the program. And finally, we handle the ready method and we implement whatever logic we want.